Welcome to clickmyproject.com. Let us discuss about the product characteristics mode analysis of a class of empirical design techniques for pro feed use lot microstrip patch antennas. Let us discuss about the abstract of the product. So in this proposed work, characteristics mode analysis of three empirical design techniques for the pro feed. So symmetrically located and use lot microstrip patch antenna and a single layer grounded substrate is presented with supporting experimental data. So the first method, so that is a resonant frequency, utilize the extension of the four distinct resonant frequency, while the second one dimensional invariant, so that is a DI, realize on the property of DI for design the use slot microstrip patch. In both of these methods, the optimization of the probe location is necessary for further enhancement of the 10 dB return loss bandwidth. So the third method, dimensionally invariant resonant frequency, that optimally combines a feature of the previous two is developed here. So and shown to be better bandwidth performance with minimal or no probe location optimization, and hence is superior to the other two rapid prototyping. So the characteristics mode analysis is carried out of the critical parameters such as a substrate electrical thickness, slot width, probe radius and field location variations. So to assess their dominant influence on the characteristics of the U-slot microstrip patch antenna. So the square in this proposed work, the square patch loaded with two U-slot start antennas is designed for WLAN and WiMAX applications. The slot antenna concept has been used in patch antenna design to maximize the return loss and reduce the antenna size. Here we are using the substrate as FR4, so the FR4's dielectric constant is 4.4. Finally, we are calculating the radiation pattern, directivity, return loss, VSWR, so that is the voltage standing wave ratio and bandwidth of the proposed antenna are calculated. So by using the HFSS 14 software package, so the HFSS means the high frequency structure simulator. So here we are using the HFSS to design the antenna of the process. Let us discuss about the flow diagram of the process. So this is a HFSS, so high frequency structure simulator. So first of all, generate a 3D structure and then solution time and then parametric model, analysis setup, result of the structure. So the 3D structure in HFSS process, we only develop a 3D domain of the process. So solution type, we calculated the eigenvalue and then it has a driven model and driven terminal of the process. Here we chosen the driven terminal of the process and then parametric model. So parametric model, here we assumption of boundaries and excitation. In the boundaries, here we using the electric field, so the assumption the perfect T, and the excitation we calculating the wave port, so we using the wave port of the process, and then excitation, so in the excitation we analyze the wave port of the process. So next we calculating the analysis setup. So in this analysis setup we calculating the frequency, so that is a start and stop frequency. Finally we calculating the results like return loss, VSWR and bandwidth of the antenna. In the analysis setup, we given a start and stop frequency of the process, and then now it's a center frequency, so that it will be designed which frequencies are like 3.5 GHz like that. So finally calculating the result of the structure. So the next process is the proposed design of the calculator of the antenna. So finally we calculated the process that is shown in the view. This is the side view representing the layers of the antenna. First of all, the substrate and then ground plane, coaxial probe and then patch of the antenna. So this is the patch, substrate, ground plane and the coaxial probe of the, so this is the overall the view, so that is a side view representation layer of the antenna of the process. So this is the design window of the process. Here we using the two U-slot antenna of the process. So this is the patch and then here we using the two U-slot and this is the substrate of the process. So by using this all the design, we calculating the result of the structure, that is radiation pattern, return loss, VSWR, bandwidth and also various type of antenna, and similarly to the 2D and 3D of the structure. So these are the overall flow diagram of the process. Let us discuss about the running procedure for the product. So here we using the process of, so this is the overall running procedure for the product. So this is a validation box. Here I be using the square patch antenna by using two U-slot. So this is one type of U-slot and this is the second U-slot. So and then next to this is substrate. So here the substrate is presented. So this is the substrate. That means that is FR4 substrate. The dielectric constant is 4.4. Here we are using the substrate of the process, and then this is the coaxial probe. So coaxial probe, like the outer layer is conducting coaxial probe, the inner layer coaxial pin, and coax outer of the process. So this is the excitation to given the process, and then next of all the so this is the boundaries. Perfect T1 for applying the patch, and then perfect T2 for applying the ground, and for the radiation box is recovered by and also predicted by the environment. So here we're using the radiation box as a process, and then excitation. So here we're using the excitation as a wayport circle, so as represented as bottom of the layer. So next is Addons setup. I told that the sweep frequencies. So the stop frequency is 4 and stop frequency is 6. So this is the start and stop frequency of the process. And then the setup. So setup here we given the solution frequency is 4.8 GHz. So this is the start and stop frequency of the process. So check the validation box. So design settings, 3D model, boundaries and excitation, miss operation, analysis setup, optometrics and radiation. So these are the validation checkbox of the process. So this is the run. Overall running the process. So here we using this button to click and then run. It's take some time to display the process. So and then finally we calculate the results of the overall all the results like return loss, VSWR, radiation pattern, like 2D and 3D of the process. So next of all calculating the result, HFSS, and then results. Create a terminal solution data report, rectangular plot. Here we selected the return loss of the process. So this is the return loss minus 10 dB. So calculating the return loss of the process. Here we are achieving the dual pattern of the antenna. And then the next figure is so this is the 3D radiation pattern. So on the 3D radiation pattern, calculating XYZ. So the red is denoting the maximum intensity of the process, and calculating the VSWR. So here we are using the VSWR like in that is calculating. So this is the one type of a dip, and then this is another one, and then 2D radiation pattern. So the 2D radiation pattern we get in like the part of the antenna, and then this is also 2D radiation pattern of the process. So here we using the radiation pattern by using the start and stop degree, and theta. So the start is equal to 0 degree and stop equal to the 360 degree. Finally calculating the process like that. So these are the overall running procedure for the process. Thank you for listening this video.